If we look at this chart gives us a good example of the relationship between decimal numbers, octal numbers, binary numbers, and hexadecimal numbers. Really the only thing that happens when we are converting these is we're changing the base. Typically, as I said in the last video, the base is typically base 10. That's the numbers we're used to using. We have 10 numbers to choose from. We have our decimal places, they all increase by 10 or decrease by a value of 10. So it's a base 10 system, which is what we normally use. So if you would see the number 3, maybe, there we go, 3, it would have a base 10, just to let you know that it is in fact 3 base 10, which is a number that we would expect to see. Now, if you look at octal and you look at hexadecimal up here in this 3 column, you can see that 3 in binary, it's not going to like that. So we can see 3 there in binary is represented the same way as 3 in octal. So if I did 3 in octal, would be 3 to the 8th base. And hex is also. Now all these are written the same way. So the decimal value, the octal value, the hexadecimal value are all the same way. The binary, of course, we said you've got a 1 and a 2, which gives you your 3. So it'd be written that way. And obviously, if we write it that way, we also want to say that it is base 2 because it's binary. Now, the thing about decimal, once you get to the 10th value, so 0 through 9 can all be written with a single digit. Once you get to 10, you have to increase the tens place. Octal, once you get to 7, if you want to represent that 8th position, you have to increase really the 8ths place. Binary, once you get to that second thing, you have to increase the 2's place. Hexadecimal, hexagon, when we think hex actually, we want to think hexadecimal, so it would be 6 and 10, 16 places. So we can represent the first 15 by the numbers 0 through 9 and then A through F. But then when we get to 16, we want to represent that 16 by increasing the 16ths place. And we'll talk more about this in class. But really this is kind of just a good chart to look at and a good way to kind of talk about our different numbers. Now we're going to talk about the number. We might as well just do, let's do 13. And we'll talk about it in octal. So if I have 13 base 10 and I want to write that as a base 8, we know that 13 we're at least going to have one full 8. So if I have my, now this is the part where it's kind of hard to explain. Here's my 8ths position here, and this I guess we could say is my 1's position here. So we're going to have 2 spots. Now it's different because we would normally think about it as our 1's place, and then our 10's place, and then our 100ths place. But that's base 10. So when we're doing base 8, we would have our 1's place and our 8th's place and our 64th's place, and it increases kind of at a different amount. So if we're doing the number 13, well, we know that there is one complete factor of 8, 5 left over. So really, the number 15 base 8 is equivalent to 13 base 10. And if we look at binary, if we're looking for the binary version of 13, well, we know we've got a 1, we've got a 2, so we have 3 total. We've got a 4, right? So we have 7 total. And then if I had an 8, that would be 15. Now, since that's 2 too many, I can take out the 2. In my 2's place now, I just have a 0. So base 2, that's a 13. And then the last one is hexadecimal. Really, hexadecimal up until 15, it's pretty simple. So if we're looking at 13, hexadecimally, base 16, we just put D, and D represents 13. Now we're going to talk about, as we continue on, because we want to be able to represent bytes of information. So this decimal scale, we want to work not just from 0 to 16, but we want to be able to work it from 0 to 255, because that's 1 byte of information. When we start to discuss colors, we start to discuss other information that's being passed, we want to be able to lump that together and be able to send a whole byte of information. But for right now, just to get used to it, working between 0 and 16, looking at those things and seeing how we can come up with our hex, our binary, and our octal relationships.